Hello guys, so we are doing a system design series, and as a part of that we are going to discuss load balancer today. So load balancer is like a pretty big topic. Yeah, there can be like a lot of things in load balancer, but as a part of keeping this discussion short, because whatever we need for the interview purpose, those are the things only we are covering as a part of this system design series. So yeah, so let's get started with the load balancer. If you're talking about what a load balancer is, let's say we have, let's say we are designing some kind of a service, and our service is initially like very small. We hosted in like one application host. So let's say the host is over here. So this is, let's say, server one. Now any client over here can directly connect to our host and to fetch that the result of the API call that client is making. Now let's say like over time our application became more and more popular, and what we are seeing is like we are adding a lot of servers. Maybe this is a S2 and this is S3, and maybe like there are more like a S4, S5. Yes, our service is doing really great, so we are scaling. Now this client is confused, like actually which server to talk to get the data. So that's when actually comes the load balancer. So what actually will happen is like we'll be putting a load balancer over here. Now this load balancer is exposed to this client. What actually this client will be talking to this load balancer, and the responsibility of the load balancer is like a route the request from the client to any of these servers. It may go to like sometimes S1, like for the same client it may go to sometime to S3, and like for different clients it will hit the load balancer, and the request may go to any of the servers. And we'll see like how exactly the routing works, the algorithms that are used in a load balancer. But this is how actually the core of the load balancer is actually it is used to route the request to the right servers. So what actually it is, by the definition, if you'll see what it is, a load balancing refers to efficiently distributing incoming network traffic across a group of backend servers. So the term efficiently is like very important over here, is because load balancing is not just about like balancing the load is like randomly. You have to do it efficiently, meaning if a server is already serving a lot of requests, the load balancer should not forward any further request to that guy. So that's what, like, you will have to do it very efficiently. So that is what actually the load balancer does for us. Acts as a traffic cope. So it's like if you see the normal traffic, the traffic cope is there who redirects the traffic like where actually it should go. So the load balancer sits in front of all the servers, and whatever the traffic that is coming, it actually routes the traffic to the right server. And you use like different kind of algorithms to route the request. And this maximizes the speed and capacity utilization and ensures that no one service is overworked, which could degrade performance. So it is like actually what the maximizes the speed. Why is that? Like, let's say like there is some server which is like overloaded, and if you will forward more requests to that guy, what will happen is that guy will actually not be able to serve the request quite efficiently and quite fast, right? There will be a lot of requests in the queue, right? So that's why like load balancer ensures that okay, it maximizes the speed and it uses all the servers efficiently. So what are the functions actually? In short, like the functions that load balancer provides are distributes the client request efficiently across multiple servers, ensures high availability and reliability by sending requests to only that servers that are online. Meaning, if some servers is dead, so load balancer will automatically remove those servers, so that like whichever are online, the request will only go to those online servers. Provides the flexibility to add or remove servers as a demand dictates. It means like, let's say your service is actually is getting more and more demand, right? You will keep on adding servers. So load balancer actually provides an easy way to add any kind of server at any point of time. And also like at any point of time, let's say like there is some server which is not healthy or not performing well, you can want to remove those. It's very easy for you to remove the servers from the server pool. Now, coming to the popular algorithms, so there are like a lot of algorithms which load balancers uses, but over here we'll be only talking about the most popular algorithms because this is most about the interviews only, and these are like I think more than sufficient. So round robin in which is a like very well-known algorithm. Round robin is it's in a sequential manner. The request first will go to the, let's say you have a 10 servers, the request will first go to the first server, then second, then third, then fourth, until the 10th server. And then then after that it repeats that again, the request will go to the first server, then second, then third, and this goes on. So there is a nothing like no any calculation that load balancer is doing. Just whenever the request is coming, whoever is the next guy to serve, the request gets forwarded to that guy. Least connections is over here. It's a little bit of computation it needs is to figure out like which server is having the least connections. Least connections means which server is processing least number of requests at that point of time. Okay, forward that request to that guy so that like he has he can actually process more requests. It has more capacity, right? Otherwise, like if we are sending the request to already overloaded, then it's going to have like more latency for processing the request. Next is hash. So hash is like a very general term, but for load balancer, what we do is like there can be IP hash, there can be like different ways to hash so that like the request should get routed to the right server. IP hash is a like very commonly used algorithm where like based on the IP, it gets passed through some kind of a hashing function and it gets routed based on that hash ID that gets generated to a right server. And it can again be like a hashed out of the any kind of a header that is getting passed as a part of the request. So it's based on again like what kind of hashing algorithm that you are implementing. Now comes the sticky session. So sticky session is also like very important kind of algorithm where actually let's say your server is doing some kind of a heavy computation and a client made a request. Your server is still like busy making computation, but it can partially give the data of your computation. So it gets the partial data, gets returned to the client, but client again has to hit to the same server because the some of the computation is still there remaining in that particular server, right? So there comes the sticky session because you need to hit to the same server again. Otherwise, if you are going to hit another server, the data is not there in that particular server, right? So there, like in the sticky session, load balancer maintains some kind of a session where actually the client request gets routed to the same server again. So that is all about the popular algorithms and the benefits that we'll see like a load balancer. What are the benefits that we're getting out of this load balancer? Reduce downtime, certainly, because whenever a server dies, then it gets removed out of the server pool. So whenever a client request comes, it always goes to the online server. Scalable at any point of time. If you would like to scale and there is some requirement to add new servers, it's very easy. Load balancer provides the flexibility for it. Redundancy, if there is some server which are not getting used properly, load balancer ensures that all the servers are properly used to their like best usage, and that's how actually our entire system is becoming more efficient. Flexibility, it's again at any point of time if you want to add or any remove any server which are not healthy, it's pretty easy, and load balancer actually helps in easy way of getting a server out or like adding any server. Efficiency, certainly like it's increasing the efficiency because whatever the servers that we have, all the requests are getting routed. If our algorithm is right, then all the requests will be evenly distributed and all servers are working in a, like a very efficient way because they are the requests are evenly distributed across all the servers. So thank you guys. That's all about the load balancer. See you in the next video. This system design interview series is more about like an interview focused series. So hope to see you, and please like and subscribe to my channel. If you like this video, please hit the like button and comment on the video. Thank you so much.